Hi, everybody. Welcome to JMBE Live for our February 2025 edition. Today, we're delighted to talk to you about a recent publication about the ASM Curriculum Guidelines for Undergraduate Microbiology. We published an update to them in 2024 after about, I think 2 years of work. And we have some of the authors of that task force and that paper to talk to you about the work that we did. So during JMBE Live, when you have questions, please put them into the Q&A box, which is at the lower part of your Zoom toolbar. We'll have lots of opportunity for a lively Q&A with our moderator today, Stanley Maloy, and all of our speakers. So whenever you have a question, just contribute it to the Q&A panel. Okay. Today's episode will be about 1 hour long, and we'll post the recording to YouTube when we're done. So JMBE is the Journal of Microbiology and Biology Education. It is an open access journal published by the American Society for Microbiology. And do catch up on all the latest and greatest scholarship on the website shown here. So one of my programs is really exciting to announce that ASM Education is going to host a new webinar series that starts at the end of March, 4-part webinar series with collaborators K-Base. We call it From Bench to Publication, Identification and Analysis of Microbial Isolate Genomes. So I'll be hosting that, Rachel Horak in the Education Department, along with my colleagues at K-Base. Registration is ongoing now. It'll be recorded in case you have to miss the live sessions. But during this series, you'll be able to learn new computational biology skills. And the audience for this webinar series is faculty, researchers, and trainees. So undergraduates, grad students, postbacks, postdocs, all would be an appropriate audience. And in a minute, I'll put the link to register in the chat box. So with that, I'm going to turn it over to our speakers today. And I'll see you at the end for a moderated chat.
Thanks, Rachel. Can you hear me okay? Yes, okay, I got a few thumbs up, great. Let's get the slides launched. All right, so on behalf of Nancy Boury and Mary Allen, I'm Dave Kushner, and we all welcome you to today's JMBE Live. We're going to take some time to talk about the updated American Society for Microbiology Curriculum Guidelines, and let's just dive right in. So just real quickly at the start, I want to mention the slides. We have a lot of slides. We're going to try and go through them a little more quickly. They're really here as a resource and reference for you. And if you don't catch something, we want to encourage you to come back when this gets posted to YouTube so you can catch the things you need. So there'll be some URLs and some QR codes. And, so don't worry if you can't quite catch them as we go. You'll certainly have a chance to grab it from YouTube afterwards. So just some general background to start to get us to where, in some ways, the original 2012 version of the guidelines were generated. So we want to kind of think back a little more than a decade ago. And so if think about what do you teach? You actually probably also want to think about who you are teaching. And so, of course, for most of us, or if not all of us in this webinar today, we're thinking about the people in our rooms. And so we're teaching our students, and we want to think about, well, what are we teaching them? And so, you have to also think about, what are you teaching them, and how do you know what they have learned? We want to make sure that they are learning things, and how do we make sure that that happens? And so, little trouble advancing the slides, apologies. There we go. All right, so if we want to think a little bit about the concepts we want to consider as biologists, we can look at a variety of references and materials that exist for us to do that. The information on this slide comes from a 2020 NSF report, National Science Foundation report on STEM education for the future. And there is a URL hiding there in the middle of the slide, but you can Google that pretty easily, 20 NSF report on STEM education, it comes right up. The key item here is really sort of in the middle, that second bullet point in that top box. Looking at what's important as we're looking forward, and this is from 5 years ago. But it's really thinking about that third line there in that second point, understanding concepts in context, and then be ready to use available computational power to accomplish tasks. But it's those concepts that are really important, and then everything can kind of fit in the context of those concepts. And so what are those concepts? And a lot of those concepts come from the really important document from around 2009, so about 15 years ago now, from the AAAS Vision and Change Report. The American Association for the Advancement of Science worked for some time to put this together and was published around 2009 or so. And so this slide and the next slide briefly review some of the key aspects from the Vision and Change report. This slide looks at the core concepts of biological literacy, and you can see on the right side, in bold, the 5 main areas that, it was determined would be good conceptual things for biologists to try and cover in their classes. So evolution, structure, function, information flow, metabolism, and systems. And then on the next slide here, we have sort of core competencies, so things, skills that we should have our students trying to work on and improve on as they go through our classes. So the process of science, using quantitative reasoning, modeling, simulations, understanding the relationship between science and society. So you have back here, concepts of biological material and then skill sets. And these items on these 2 slides really drove the generation of the original set of curricular guidelines for microbiology education that was published in 2012. And it seemed like it was time for an update. And so Mary's going to take over here and talk a little bit about that.
Thanks, Dave. So why revise the curriculum guidelines? I mean, the previous group put in a huge amount of work and gave us something that's been really valuable. I myself have used the curriculum guidelines since they were originally published. But all things, right, we're scientists and science progresses, and all things rely on us taking another look and seeing if some kind of modification is necessary. So one of the things that was noted is that many of the prior fundamental statements were central to one group of microbe, and the task force this time around sought to expand that by using the term microbe place to be more broad in our consideration. And we used the other curriculum guidelines that have been developed since the initial ASM curriculum guidelines were developed to help guide our changes to ours. So we're really seeing an expansion within the field of science of these curriculum guidelines that was good to incorporate. And ASM itself had reorganized from over 20 divisions into 3 categories. And inside of those 3 categories, education and policy are embedded. So they touch all aspects of those 3 categories. Dave, next slide, please. So here are those 3 scientific units. And really what we wanted to make sure in the curriculum guidelines was that they reflected all of these units, the 3 units and the different sub-pieces in it, so that as each individual, each of us who are professionals are sort of thinking about the field, we're also thinking about how that touches on education. Next slide, please. So what are some changes that were made? As I said before, we shifted the terminology to microbe and also included viruses and other subcellular agents. We made some minor changes in phrasing for clarity, and some statements were combined so that the statements don't just get longer and longer and longer, right? One hazard of making modifications. And we added fundamental statements that focused on reproduction, obligate intracellular parasites, unculturable organisms, the One Health paradigm, and the recognition that although some microbes are pathogens, most or many are not. Next slide, please. So how can the curriculum guidelines be used in our work? Next slide. One way is that they can be applied to course design. So many of us, I have used the original curriculum guidelines a lot as a guide to how I actually think about what I want my students to learn. I use them to help me identify learning outcomes, my desired results. I use them to think about how I can develop my assessments. What do I want more specifically are my students to actually be able to demonstrate to me? And then I use that to plan learning experiences and instruction. And we're seeing, including in the fabulous book that Rachel Horak is an author on, published by ASM, the microbe textbook, that they have learning objectives that are aligned with vision and change and our fundamental statements. So they're really useful tools in that regard. Next slide.
Okay, so just I'll take a second to take over from Mary here, just to point out one of the things that Mary mentioned a minute ago was sort of the expansion of the guidelines from bacteria-centric or mostly bacteria-centric to microbe, and trying to, help folks who are teaching with more background in bacteria to realize there are resources for you to help you expand past bacteria when you're teaching microbiology. And one of those resources is a set of virology guidelines. And so when you're teaching about bacteria, we're hoping you can also find ways to add in a little bit about viruses and fungi and things like that. But for virology, a group of folks starting in about 2022, 2021, put together some guidelines for virology undergraduate education. So ASM is been gracious about allowing us to sort of build that in together so that you can take advantage of all the resources to help you. So this is just a list of some of the virology curricular guidelines for folks who are going to try and just teach a small chunk of virology within their microbiology course. So there's a much larger list for people teaching a complete virology course. Here's a subset of items that might be good to try and incorporate into a microbiology course. And this content is available at the American Society for Virology website and is also mentioned in the JMBE papers. One of the things that you might be maybe a little surprised to recognize is that the new updated ASM Undergraduate Microbiology Curricular Guidelines, a lot of them really overlap or very almost identical with the virology guidelines that were written and put out in 2022. So this is just one example. So we have categories that are vision and change kind of related. So impacts, so impact of microbes. You have in the middle of the screen there, a fundamental statement about the impact of microbes from the microbiology guidelines, and underneath it is one that came from the virology guidelines. And in blue, you see very, very similar language. So the idea is if you're talking about impact of microbes as a concept in your class, and you want to talk about, a minority of microbes are pathogens, people often think about, we got to focus on the pathogens, but we know that's very, very few, but there are ones that can impact the environment and ecosystems. And that's true for bacteria, it's true for viruses. And you can have an example of a bacterium and you can put in an example of a virus. Should be pretty easy to try and add those things in. All right, we're gonna move over to Nancy now to talk about some more application of the guidelines.
Well, hello all. In addition to applying the guidelines to course design, you can go up kind of one notch of complexity to look at your entire curriculum. If you're in a larger school and you have multiple microbiology courses or microbiology, virology, mycology, different types of courses, and it is an entire curriculum, you want to make sure that your courses in all of your courses as they're put together in an entire program of study, the students are exposed to these different concepts at different levels in their curriculum. So, you know, maybe their first year or first exposure, they'll introduce a concept. In the second year or second course, they have it reinforced. And then the third, kind of the score of 3 would be mastery. And if we're looking at this in terms of what the students are able to do, they're able to look at a given concept in various different levels and at various different comfort. Next slide. If you're going to map out your curriculum, the topic is called, or the process is called curriculum mapping, and you can look at like different courses, and what you see here is the core of the microbiology curriculum at Iowa State University. We are fortunate enough to be a large land grant R1, so we have lots of different micro courses. So we want to look at in this case, evolution. We want to look at one of the categories and then say, well, when are the students introduced? When is it reinforced, and do they get to mastery? And then we kind of look at this in this case, it's as a heat map, and we can see, you know, we're looking for gaps, we're looking for overlaps. And in this case, we see that number 4, the next time we reevaluate our courses, or as you build the courses out, we're going to add some more phylogenetic trees. I happen to teach a couple of these courses, and there will be some phylogenetic trees added, just saying. Next slide. The other reason we might want to do this is, you know, publications. There are learning frameworks, both JMBE and ASM, like JMBE is looking at the fundamental statements and guidelines as you're preparing a curriculum paper. One of the things that we do is we look at what the activity is you're doing, how does it align with the fundamental statements? Other outlets like CourseSource also have a learning framework. And what this does is it provides consistency in curricular resources. Say I want to look at, you know, how humans impact the environment. I have multiple different articles in the microbiology learning framework available on CourseSource. And so it really does give you the opportunity to not reinvent the wheel. You can look at what other people have done and published. And when you're publishing, you can kind of look for gaps and say, oh, this needs to be, you know, we need more activities in this area. This is where I'm going to address that gap. Next slide, please. The next step we're going to be doing is building learning outcomes. And as we have a fundamental statement that addresses a concept, but these concepts are not measurable. So learning outcomes, you know, one of the common definitions here are that a learning outcome is a statement of what a learner knows, what they understand, and what they are able to do. They typically have a what we call the SWABAT format. Students will be able to whatever it is you want them to do. And we want to state a condition. We want to describe what performance that is. We want to know what the criteria is. And then the key thing that differentiates a learning outcome or learning objective from our conceptual fundamental statements is the learning outcomes / objectives are a measurable thing. So after this activity, or upon completion of this course, or when, state the condition, the student will be able to, that's the focus on the students. And then you describe what level you want them to do. In this case, it's state. And now, like, the criteria are 2 characteristics that all living cells share. And then for like measuring this, an easy way to assess this would be to ask them to share or state or do something along those lines. Next slide. So if we look at this in terms of an entire curriculum, and when we say students should be introduced to concepts, they should practice or have reinforcement, and then they should have mastery. This is kind of an example of a single fundamental statement. In this case, we're looking at regulation of genes and in external and internal molecular cues. The introductory statements are really, you know, what is an operon? How does an operon work? And they are lower level blooms. The practice are kind of medium level blooms, you know, explain when you might have an activator protein. How are 2 component signaling, you know, how does that work? And what is quorum sensing and how does that regulate gene expression? And then mastery, these are the example here is from courses at Iowa State. These are 400 level courses where we're looking at this concept in specific cases. So designing inoculants, looking at plant engineering strategies, that we look at virulence gene expression. So that's the application, the evaluation and creation or higher order blooms. So this is just an example with one. Next slide, please. So I invite my co-speakers here. We're organizing a task force to build out example learning outcomes based on the newly updated fundamental statements. Mary and I are co-leading, and we do have both the QR code with the bit.ly QR code, and it's a Google form to fill out. And I see Rachel put the link directly in the chat as well. We want to work with faculty to develop lots of different examples because different courses do different things and have different emphases. Mary, your thoughts?
I think Nancy said it really well. We want as much input from people who are teaching different kinds of courses, approaching their teaching in a different way, teaching different groups of students. So the more variation in input, the better.
Next slide.
Yeah, just real quickly, I'll add that one of the that's okay. No worries, Nancy. One of the nice things, hopefully nice things for the community is that after the virology curriculum guidelines were developed, some of those folks and some new folks got together and worked for a couple of years, and in 2024 released a set of LOs for the virology curriculum guidelines, which many, if not most, if not really all, could potentially be used by folks teaching microbiology. And so there is no need to reinvent that wheel, which is great. It'll allow for the new microbiology specific task force to focus a little bit more on microbes generally, but don't have to spend time trying to think about viruses so much because there's already material available for folks to use in that area. And next slide. Go ahead, Nancy.
Oh, actually, you should probably forward a couple of
yeah.
it's animated. There we go. So really what we're asking for it's all the same Google Doc, but what we want is really feedback from you as to how you use the ASM curriculum guidelines currently, or do you have future plans? And if we provided example student learning outcomes, because we're planning on it, are you planning, how are you using them both in a curriculum perspective as an individual course, or even more fine-grained, like, do you use them with an activity within a single course? And I think any other input from everybody else? What questions does the group have? And I know Stanley said he has questions for us, and I see some questions in the Q&A. So we're happy to answer.
Thank you very much. That was a really nice summary of things. And the first question I was going to ask was about the microbiology concept inventory and updating that inventory. And so it's clear that that is an ongoing process. But when you think about the concept inventory, it also leads you to think about the issue of sample questions that you might ask. And so we have a couple of questions about whether there will be an updated version of the ASM sample questions in microbiology and also sample questions in virology.
I can start that. So Dave, will you be able to take down the screen sharing? Cool, great. Okay, so ASM sample questions in microbiology was a big group effort, started at the 2014 Conference for Undergraduate Educators. And it was one of my favorite projects to work with when I was a postdoc at ASM in 2015. So what it is how we did it is we took learning outcomes that the community contributed to ASM, and then we asked the community to contribute sample questions that are aligned to those ASM curriculum aligned learning outcomes. And it was a collection of over 200 sample questions for microbiology that cover the full breadth of the curriculum guidelines, and they cover a wide variety of Bloom's levels. So we took the questions and we bloomed them to each of the 6 levels. And so if you're in the microbiology textbook, so one of the supplementary features for educators of the microbe textbook is the ASM sample questions in microbiology. So that's how you can get that 2016 version. At this time, we haven't gotten to the point where we're ready to contribute another sample questions. It was a 2-year effort, and we do have to do the learning outcomes first. So we'll do learning outcomes, and then we'll think about if we can work on updating the concept inventory and the sample questions. And then I'll turn it over to Dave to talk about whether they have something like this for virology.
Right. So that's a really good question. And I'll say that at the current time, we're not working on setting up questions or trying to collect and collate questions. It is a good idea. It is on the list. But right now it is not something that's happening in the immediate future, mostly because of the number of people and the amount of time that is available for such work, but it is on the list and it might happen. It might be good to coordinate with ASM and actually do that one together when the ASM micro folks finish up with the LOs.
Thanks very much. I might mention to the audience that in addition to being our host, Rachel also served on the team that helped build these guidelines. And so she's serving today both as a host and as one of the people who might answer some of the questions. So that's what's going on here. This is a follow-up, and it's because you guys aren't just moving fast enough, I guess, but the question is another aspect of microbiology that's very important has to do with nursing and allied health. And so the question is there a plan to update the nursing microbiology course information, or is there an expectation that they will begin to merge more with the general microbiology course guidelines?
I can start. So all of these efforts that you're hearing about today have been spearheaded by volunteers through ASM, right? I'm staff, and everybody else you see here on the screen are all dedicated ASM volunteers. And so my role is to find people who can help us do the work. And all I do is help gather people and then spread the word, right? But the actual work has been initiated, led, and done by all of our volunteers. So with that said, if anybody wants to do work on updating curriculum guidelines for allied health or nursing, send me a message and say, I want to lead this effort, and we can start a discussion.
And again, another core part of thinking about microbiology has to do with thinking about immunology and host response when you do have those pathogens, even though they're few, David. So the next question is there an effort to build more of those immunology guidelines and learning outcomes for them? And if so, can you provide a link that would help somebody see what's happening?
I can probably talk about this, and Nancy, you can probably fill in what I miss, because Nancy and I talked about immunology quite a bit during the curricular guidelines revisions. So there are some immunology guidelines out there. There seems to be a couple of sets of guidelines out there that were done by different groups of immunologists. They're pretty in depth is probably one way to try and describe it. So I think the one answer is there are some resources available. Are they as easily digestible and movable into your course as they might be? Maybe, maybe not. But there are some resources. So I think trying to maybe use formulate some ideas of what key immunological concepts you might want to include in your class, and then trying to extract out a few of the examples from the immunology guidelines that do exist might be one way to try and approach it. But whether or not the micro set would incorporate immuno guidelines, maybe in the next round in a while. Nancy, did I miss anything, or do you want to add anything to that comment?
No, I think you summarized it really well. I just went to look for the I know there is a Journal of Immunology article that lists out a lot of the immunology guidelines, but what they have listed in that article is very comprehensive, and it is more fine-grained and specific than conceptual. And so if that's what you want, it gives a really good guideline. Like if you're teaching a 400, 500 level immunology course, it would be a really good place to start. But it isn't as conceptual, and it doesn't have the flexibility that, the more generalized statements do. And that it's just two different ways of thinking about this process. Neither one's right or wrong. It's just different.
Can I add too? I know the American Society for Biochemistry also has, and molecular biology also has curriculum guidelines. And I know that some of us emphasize more of that potentially in our curricula and in our courses. I think, for the task force working on the ASM curriculum guidelines, I think this was true for the first and the second task force. We wanted to make these actually a number that was reasonable to be able to apply to a single undergraduate microbiology class. So I think it's worth thinking that, considering that we can't possibly include everything, which is sort of part of what Vision and Change was about. There are these overarching concepts, and in the ASM curriculum guidelines, these are to some extent overarching fundamental statements. And within each of those statements, you may decide to apply your own level of detail. And you may decide that some are more applicable to your class because others are addressed in other courses. So I think the idea is that they're flexible and user-friendly and applicable to a lot of different situations.
I'd like to reiterate something that each of you said during the presentation, and that is that these guidelines are really based upon what we've learned about how people learn. And so it's different than a bunch of details that somebody thinks students should know, right? And I think it's really important to keep that in mind. And if you are somebody interested in immunology and you want to develop the immunology guidelines, you should look very hard at these ones and ask some of the people who are involved for advice about what you might do going forward, right? Is that fair? Okay, all right. One of the key things when you develop guidelines is they're only effective if they're used, right? There's always this fear that it's like a book stuck on some dusty shelf in the back of the library that doesn't get pulled out very often. Do you have an idea of how widely the previous guidelines were used, so that you can think about how much impact you're having on microbiology education overall?
So I wrote a paper about that in 2015 or 2016. And, the word used can mean lots of different things, right? You can read them and then take pieces of it and put it in your classroom, or you can develop your entire microbiology 4-year bachelor's program over them, right? And so what I found with a survey of the microbiology education community is we found at least several hundred educators have read them, downloaded them, and at least developed some learning outcomes around those. But I think it is taking a further look at it, because Vision and Change continues to be really important, right? And the idea that science is always changing, but the fundamental concepts and the fundamental understanding of what we think as as a group of microbiologists is important, doesn't too much, right? You know, if you look at the guidelines, these are 28 statements or 29 statements that cover the full suite of all microbiology field, right? And so my expectation is that you are using it in some form, right? Because I bet everybody's teaching horizontal gene transfer. Everyone's teaching something about phylogenetic trees. So I do recommend, you know, taking a look at them and thinking about what are some ways that you can apply them in your own classroom, and start small, right? Make one small change and try to think of it, because we did take, this was a, you know, a 13 or 14 person task force that took 2 years of effort that said, all right, this is the field of microbiology. And we took outside sources too, like we took industry representatives, we looked at the field as a whole. And I think that they're very, very useful to a lot of different institutional and a lot of educational contexts.
So to follow up on that specifically for you, Rachel, you are a co-author of the 3rd edition of Microbe, a widely used microbiology textbook. And based on your experience working with this task force, you have integrated those concepts into the textbook. And I understand other microbiology textbooks have done so too. Presumably that relates to how you would pose the questions at the end of the chapter in the textbook and how you would have other learning resources. Could you just comment on that briefly?
Yeah, that's absolutely true. So what we did with the Microbe 3rd edition textbook is take those curriculum guidelines and apply them to each chapter, right? So if we touch on these concepts in evolution, where are they in the textbook, right? And so we made sure that all of these fundamental statements are through the textbook, and then we align our learning outcomes to those fundamental statements. So you could use that as one model of how to bring the guidelines into your classroom.
So another question was, how do you make sure that these guidelines stay aligned with real world challenges? What's happening with antimicrobial resistance, emerging pathogens, rapid diagnostics, all of these things that impact people's lives, right?
Well, I'll jump forward. One of the reasons we decided to, like, as we're building the new guidelines and with the original guidelines as well, is they're not specific to, we're just going to talk about antibiotic resistance. We talk about the fact that the environment changes microbes and microbes change the environment. And within that context, now I can talk about antibiotic resistance. I can talk about the use of antibiotics. I can talk about the development of antibiotics from other microbes and sources for other mechanisms by which we can control bacterial growth, which, by the way, is what I just did this morning in class. So it's a way to look at things, like take that one more step up, and the 30,000-foot view of, we need to address this conceptually. What is this concept? And then you can have multiple different examples. That was one of the reasons why we put One Health into the new guidelines, because it's a really good way to integrate multiple disciplines. And what do everybody else think about that?
I would agree. I was going to say, I think this is actually, I would suggest one of the big points of discussion amongst the task force was how to be specific enough to have them be useful and general enough for them to be encompassing of different points of specific information that an instructor might want to use as an example. And so you're really trying to find a balance between those two components. And so in principle, they should be general enough that as the field changes, we updated them, right, to reflect changes in the field. And eventually, I imagine they'll be updated again to reflect further changes in the field. But if we're talking about further understanding of how, for example, certain chemicals impact microbes and where those come from, and how that evolves, how that involves natural selection and other things. I think that's always it's always been there. It's going to continue to be there because those are the big overarching concepts, and they're reflected.
So there's two other questions that relate to pushing these ideas internationally, right? And although vision and change really reflected how people everywhere learn, sometimes these concepts are viewed as being very US centric. So really the question is, hey, is there going to be an effort to push them more broadly internationally to get input from the international community? And that includes thinking about terms that might not be used widely in other places that are more common in the US scientific enterprise.
I'll start just by saying I'm not, I'll let Rachel and others sort of speak to what, because Nancy's the chair of our subcommittee on undergraduate microbiology education. So I'll let them speak a little bit to what the future plans are. But I will say that the Federation of European Microbial Sciences, FEMS, used the initial curriculum guidelines. Their education board used those to begin to develop their own set of guidelines. And so they have something, it's quite different than ours, but, and of course, as you point out, Stanley, because the way that teaching and education happens across the globe is quite different than the way that we do it. But I think that we're starting to see those trickle out. And I think I would argue there's really great opportunity for us to be in greater dialogue with those organizations across the world to see how we really can incorporate their experiences into our future guidelines, and in turn, we can be better educators of international students, right? But wherever they may be learning.
So I'll just add that JMBE has a lot of international authors that publish on education research, and we're really trying to reach out to build more of that process based on the idea that some of the things that we've developed can be useful elsewhere in the world, and we can learn things that are really valuable from places elsewhere in the world as well. So we really think that science and education are international endeavors, and we hope we can push that forward. So, Mohammed asked the question, how will you make sure, he asked 3 questions in a row here. How are you going to make sure that these learning objectives are adaptable across educational institutions? And will there be training sessions for educators on how they might use these more effectively? And also, are you getting input from the students? Instead of just feedback from other scientists, what about the students?
I'll take the first shot at this one. We will, we're right now in the gathering phase to try to establish the task force for the learning objectives. And we want to make sure, as we form groups, that we have a large diversity of people's experiences. So not just R1 institutions, not just schools that we might be, talking about that have a whole bunch of resources. We want to make sure that, we include other schools, community colleges, if we can get people that are teaching, courses that work with your PSEO courses where you have high school students getting college credit, some of those type levels of learning objectives. So we want to make sure we get a lot of different voices. I love the idea of having student input. I think as part of the process, we will probably include students that are in our courses to say, this is what we're thinking, and maybe ask them how they interpret learning objectives. So that's the other piece to this. But really, the idea behind having lots of different example learning objectives is that not any one school is probably, or one situation is probably going to use them all, but we want to give examples that would work in multiple different contexts and across lower order and higher order blooms, because it really is going to vary into which course you're teaching and the context in which you're teaching it.
So maybe, Rachel, maybe you could comment on whether there's a possibility for training sessions on the guidelines.
That's right. So the best place for that would be the ASM Conference for Undergraduate Educators. So this is a conference, you can look it up, asm.org/ASMCUE. And there we offer lots of opportunities for educators from around the world to come together and think about how are we going to bring guidelines from international organizations into your classroom, how to do it well, and meet other people who are doing the same things as you are, right? So we'll have a fall meeting in San Antonio this year. And spoiler alert, we're going to have a summer webinar series. So check back to the ASMQ website for more information. You can join us this summer for some sessions on how to do these kinds of things. And I'll make a quick comment. The question, one of Stanley's questions was from Mohammed was, can students provide feedback on how curriculum is affecting their learning experience? That would be a great SOTL project or a DVER project, right? If someone wants to take that on, you could do some surveys and assessments and see how this kind of curriculum impacts their student learning. We would love to have the results in JMBE.
And this may also be another good DBER project, but a question came up about taking these kinds of concepts from a traditional classroom and integrate them into different modalities of teaching, and how easy that would be or not. Any comments on that?
So Stanley, are you asking sort of using them in teaching that is something other than just speaking to your students from the front of the room? Yeah.
Yes.
I mean, I actually think they're really, really well poised for that use. I use them a lot that way. I have used them actually as essay test questions, open book essay test questions, where students have to sort of provide examples to support the statement, for example, or even closed book using material that we've covered in classes. They can choose from a variety of different examples. And you can, as you know, you can use them to design activities because they can help you figure out a system that you want. You can have the overarching fundamental statement, and then you can say, okay, I'm going to zero in on a particular sort of example of that fundamental statement or multiple examples. And maybe I could do a jigsaw where I had one group of students looking at one example and another at another and another, and you could swap them around. So you represent to the students that there's not one way of thinking about this fundamental statement, that it's an overarching statement that's represented by a lot of specific examples. So yeah, I think it lends itself to engage teaching in lots of different ways.
I might add, I think part of the concept there was that the guidelines you built are really based on the concept of active learning. And there are still people who think that active learning is very hard to integrate into a very large classroom setting or an online setting. But in fact, there are ways of really nicely doing that. And there are some wonderful articles in JMBE. One of the things is a special issue on teaching during the COVID crisis, and there's a lot of content there about how you can take these core concepts about how people learn and move them online if that's how you teach. So you might look that up. Right? One of the things that we've talked about, I think Nancy mentioned reaching back into high schools and all kinds of different institutions, but there also is a real critical need for public understanding of science. This is something I think you've mentioned in the virology realm, David. And it's interesting to think about, in addition to core concepts every student should know, is it possible to think of a concept inventory for public understanding of microbiology writ large, right? And would it be different than those concepts that you have for undergraduate education? Don't all jump at once.
I'm actually looking up a paper that was published a few years ago, and it's from memory. It was something to the extent or to the idea of the critical need for microbiology literacy. And it was this paper was published pre-COVID, but it really talked about these are the core things that, the general public should know, like, how is nitrogen fixed? What are the roles of microbes in climate change, and so on and so forth. So I was going to drop that in the chat because it was a really comprehensive paper. I just don't have it, like the reference for it right off the top of my head.
Hey, Nancy, is that the 2019 Timmons paper that's cited in the JMBE article?
It is indeed that exact paper.
I believe that is reference 1 in our paper.
There
So,
is a reason for that.
so it should be easily found. Yeah.
It's a great paper and reflects an international movement that hopefully will continue to gain steam. So,
Stanley, your question is really important, though, and it's important for all of microbiology, of course. But I think sort of in the very recent environment, thinking about it in terms of the importance with virology is extremely critical, considering where things are right now in the US, and trying to find any way we can to engage the general public as broadly as possible as to the importance of the things we all do, not just virologists, but all of us in microbiology, really is very important. Of course, lots of people have made lots of effort to try and do this, but it is a continuing, challenging uphill battle that we all kind of need to keep trying to work on. It's certainly a big challenge for all of us right now, for sure.
Many years ago, there was a button passed around ASM saying microbes touch everything. And I think that's one of the things that ties to this and what you said, David, the fact that farmers need to be thinking about microbes if they're going to have a good crop, and microbes affect our economy and they affect all these things. They also affect pathogens, even though, as you mentioned, David, the pathogens are rare. And so I think those are real points that hopefully we'll be able to help the public.
Yeah, I mean, that last point's really important, though, because most people don't know that most microbes do not cause disease, because generally all the hype is about the ones that do, right? So how can we try and help change that narrative? That's a big ask, but it's a pretty important one, right?
Absolutely. Well, this has been a really engaging conversation. I think that the curriculum guidelines and the additional things you're working on help build the utility of these guidelines will really have a great impact on microbiology. And all of us who teach microbiology will help us teach better, more effectively. So thank you very much for your volunteer efforts to make this happen and for your passion for microbiology and teaching. So with that, I'm going to turn it back over to Rachel.
Just reiterate, thank you, volunteers. Working on curriculum guidelines and thinking about the field of microbiology and how do we bring it into undergraduate classrooms is my favorite thing to do in my role as a staff member at ASM. And I really enjoyed working with the entire task force on the curriculum guidelines. So a couple of announcements. So our next webinar will be on, okay, hang on, I know this date. Okay, here we go. It'll be on Friday, March 28th at 1 p.m. Eastern Time. And the topic will be how students are taking introductory biology experience. Oh, wait, sorry, let me say it again. How students taking introductory biology experience the chemistry content. Okay. And then we'll have another event on Friday, March 2nd at 1 p.m. Eastern Time entitled Teaching with TED, a curated set of TED Talks and discussion prompts for microbiology and cellular biology courses. So registration for those will be up shortly on the website that I put in the chat, our JMBE Live website. And again, we're offering them free of charge for anybody that wants to attend. And then we record them and put it on our YouTube playlist. If you want to check out our YouTube playlist, there is a button on the bottom of our JMBE Live website to view the recordings. I think our library is approaching 30 recordings or so now. It's really exciting to see it grow and to show the world our wonderful scholarship that's published in JMBE. So with that, thank you for attending, and we hope to see you at another JMBE Live in another month.